Okay, I find that I need to repeat the idea of a slope graph, and I'm going to do that rather quickly. Okay, we have a graph. And we have the slope graph. Now, we construct the slope graph from our graph. I just used 3 points on this particular graph. I sketched a tangent line at this point, where the x-coordinate was this. I sketched a tangent line at this point, where the x-coordinate was here. And at this point here, with x-coordinate down here, I sketched another tangent line. Now, I haven't, not all these things are done with great accuracy, but you get the idea. So, here I do a triangle that shows the rise and the run between 2 points of the first tangent line. Then, using the same run, I sketch triangles representing the slope between 2 points, the triangles you'd use to calculate the slope between 2 points on the second and on the third tangent lines. Not done with great accuracy. I can see flaws very easily when I look at it, and you can probably see them too. As we pointed out before, if the slope of this tangent line is twice the slope of this tangent line, it is, and it's less than that, but if this slope was twice this slope, then this rise here would be twice this rise, because the run is the same in both cases. In each case, we'd be dividing the different rises by the same run, so that these segments here can be used to represent the slopes if we want to. There's no scale on this graph. Okay, so we don't have any way of knowing what the run is or what the rise actually is. So we don't know what the slope actually is. What we do know is if this is twice as big as this, then this slope is twice as big as this. If this is 3 times as big as this, then this slope is 3 times as big as this. Okay, so what I do is I simply bring this segment down here to the same x-coordinate and plot a point on this graph. This is going to be my slope graph. This graph will represent the behavior of the slopes of this graph as x changes. Okay, then I take this segment here and bring it down and construct, I plot a point here. And then same thing here. So that I put one line through here to show that this segment is the same as this segment, which has one line through it. And just using the standard type of notation we use in geometry. And I'll put 2 lines through this to indicate this is congruent to this, and 3 lines here to indicate that these 2 segments are congruent. So whatever the slopes are, they follow this pattern. Now, that's kind of a low, narrow graph, and I don't know if that's supposed to be a straight line or concave up or concave down or what. And matter of fact, the estimates I made here don't make a whole lot of sense as a representation of a power function graph, at least, assuming this is a representation of a power function graph, and you could easily test that. That's not important. We're just trying to get the idea of a slope graph and how it might be constructed. If I want a graph that uses up more of the graph area, I could easily just double these. Okay, double them, double them, double them. If these are linear, then when the y values are doubled, these will be linear. Okay? Now again, I don't know if these are linear. I used a straight line because I couldn't get any curve that would reasonably go through the points. In a straight line, if we assume there's some error in estimating the slopes or in estimating the x-coordinates, straight line approximation isn't bad. Okay? Now I don't know if that's the right approximation for this graph or not, though. But we see how to construct a slope graph. So we got 3 points here. Now if we did this and we got 3 points that looked like this, then we could pretty well say that that graph is concave up. If the 3 points look like this, then it really does look like the graph is concave down. If the 3 points look like this, then it's very plausible that the actual trend of the slopes is represented by a straight line graph. Okay? Now, probably really isn't exactly represented by a straight line graph, but it might be that we can't tell for sure that it isn't a straight line. Okay? Whereas here or here, we're pretty sure that it certainly isn't a straight line. Okay, well, again, the idea of a slope graph and just another demonstration.